pollen?
Well, we haven't. I haven't analyzed all the samples yet, so
Okay.
I don't know whether it's going to answer the question that I'm interested in.
Because you were clearly very close to the limit.
Yes, yeah, that was the point. I wanted to be across the limit, and so I was looking at pollen production.
I know that if you're interested, I know that we have set a pollen trap up to James Bay because we collect charcoal and pollen. So, and it's Olivier Blarquez, who is a new professor at Université de Montréal, who is taking care of it. So if you want to have, I'm sure that he could share the
So he's doing the pollen on it?
Yeah.
Okay.
So,
Well, that's
because we were mainly interested to charcoal, just to see what happened, and they were unhappy to see that when there's a big fire, even the big charcoal are traveling a lot.
Oh, are they?
Yeah. So it make things more difficult to interpret the fire history.
Yeah, because what do they consider big?
I cannot tell you.
Because it's usually 150 to 200.
Yeah, but I had to check in the paper, but I think that there were an influx of.
Have they published that?
Yeah, it's published in the article. It's in a Earth Science journal. If you contact me, I'll send it. Okay, because they were a little bit shaky about this. So now they work more with the decrease in size, with the slope of decrease in size, which give you an idea that there's enough big compared to the small. That means that it's local rather than external. So it's quite tricky, but you know this business.
Yeah, nice talking to you. Look forward to it.
seat there.
Yeah.
Perfect.
Oh, sorry.
thank you all for coming. It's my pleasure to welcome you to the Royal Society of Canada's Romanowski lecture series entitled Toward Ecosystem Management of the Canadian Boreal Forest with Dr. Yves Bergeron. Dr. Bergeron is a Canada Research Chair in Ecology and Sustainable Forest Management at the University of Quebec. He received his PhD in Biological Science at the University of Montreal in 1983 and has worked at the University of Quebec since 1985. Dr. Bergeron's research investigates the role that both human and natural disturbances like fire, pests, and climate play in establishing and maintaining forest ecosystems. He's particularly interested in the impacts that conventional forest management has on biodiversity, productivity, and resilience in boreal forests. He aims to use these findings to identify innovative forest management strategies that will emulate natural disturbances and reduce the gap between natural and managed stands. Please help me give a warm welcome to Dr. Bergeron.
Thank you. Okay, so thank you very much. Hi, everybody. I'm particularly glad to be here at UNB. I don't have a slide to acknowledge my collaborator to this work, but one very close collaborator is Brian Harvey, who is professor now at the University of Quebec in Abitibi-Témiscamingue. And Brian did this training here at UNB long time ago. I'm sure few people remember him, but anyway, he was very influential in the development of the research we've done in sustainable forestry. So I have to push on the good button. So I'll just start making a little bit of a history about sustainable forest management. Of course, there's a long history in Canada, but for me, it has started in 1985, where these committee of forest minister described the different criteria of a sustainable forest management. And just go towards the criteria. If you look at the first four criteria: conservation of biological diversity, maintenance and enhancements of forest ecosystem condition of productivity, conservation of soil and water resources, and forest ecosystem contribution to global environmental cycle. These four criteria deal a lot with ecology and understanding of ecosystem, and how we can go from our understanding of ecosystem to forest management. Of course, there's also other criteria that are important. The multiple benefit to society. It has to provide a good economy and accepting society responsibility for sustainable development. But what I will talk about today, it's mainly concerned the first four criteria. And this criteria can be attained in some way with these working hypothesis, or the natural disturbance paradigm, that we could use forest dynamic as a model for managing the forest ecosystem management. And this was really the founding paradigm of the network of a center of excellence that was developed in 1995 around Canada. It was this network was the head office, if we want, of the network, but University of Alberta. But there were people from all province and all forestry faculty or biological department who works in this network, and I think it was clearly influential on the way we manage the forest in Canada now. So most Canadian forestry researcher, and the approach is currently implemented in several provinces. So on our side, from the work we did in collaboration with this network of Center of Excellence, we published a book, a group of collaborators on ecosystem management in the boreal forest, and then we put a definition that The ecosystem management was a management approach that aimed to maintain healthy and resilient forest ecosystem by focusing on the reduction of difference between natural and managed landscape to ensure long-term maintenance of ecosystem function and thereby retain the social and economic benefit they provide to the society. The main part that's to be retained is that what we target is to try to look at the natural disturbance and how it controls the dynamic of forest. On the other hand, to look at what is possible to do with silviculture and what is economically possible, and try to reduce the distance between the two. It's not mimicking natural disturbance, it's to take the natural disturbance as a template, if you want, to try to influence the way we are doing the forest management and the silviculture in the landscape. So the idea is that if we the maintenance of ecosystem function would allow for long-term productivity, all the ecological services, resilience to natural disturbance, adaptation to climate change, economic benefit, and social acceptability. It's quite different than what was quite popular in the past, which is integrated management, which by difference with ecosystem management is that integrated management is to share the resource, but sometimes you share the resource and you have a depletion of the resource. So ecosystem management in some way is to grow the apple tree that everybody could have access to. Maintaining the biodiversity, the best hypothesis is that if you keep forest ecosystem in their natural range of variability, it's the best hypothesis we have for maintaining biodiversity. If we maintain the habitat, we should be able to maintain most of the inhabitants in the forest. The idea is that we should avoid putting the species in something we're not used to, although I'm sure that the moose could survive with McDonald's for at least for a while. So what is interesting is that it thinks we were very convincing, and that at least in Quebec, because they change in the sustainable, the Forest Act in Quebec recently, and in the Forest Act, ecosystem management is specifically mentioned. In the first article, it says that we should implement sustainable forest development, in particular through ecosystem-based development. And in the Article 4, it's that they define ecosystem-based development in a similar way that it was defined in the book. That means the development that consists in ensuring the preservation of the biodiversity and viability of ecosystem by reducing the difference between developed and natural forest. So now in Quebec, we are in this process of doing forestry on the base of ecosystem management. I'll be very transparent in my presentation, showing that we are partially do it. It's not perfect, and there's a big problem with the implementation. So the way it could be implemented is that the first two. Here I have a kind of a flow chart that show how it should be done. It's from the people that work at the ministry. It's first we have to reconstruct the natural disturbance regime. So we have to know how naturally the forests were disturbed. We should then compare the natural landscape with the managed landscape, and when we can evaluate what are the main issue or the main difference between the two. And then we can develop a different silvicultural approach to try to decrease the difference between the two. But of course it has to be implemented in the context of economy and social acceptability, which is sometimes the place where it starts to become very difficult. And we have to monitor and do adaptive management and follow what we do and maybe change and put forward new objectives. So I'll describe this approach using the boreal forests, mainly the work we've done in the eastern part of the boreal forest, Quebec and Ontario. And I will insist on the disturbance on fire. But of course, it should be applied to any type of disturbance. I think here at UNB you have Dave McLean, for instance, who has applied it to spruce budworm outbreak, and it could be applied in the sugar maple forest with gap dynamics. But I will insist mainly, or as example, as with fire, which is it's the most important disturbance in the boreal. So we can describe the natural range of variability with 3 axes when we think of fire. The fire can occur at different intervals. You can have 2 fire in 2 successive years in a row, or you can wait 500 years or 1,000 years between the 2 fires. So there's a variability in the return interval. The area that burned could be very small, or it could be a huge fire. We had a fire of 5,000 square kilometers 2 or 3 years ago in the northern part of Quebec. Of course, it's not every year that you have these big fire, but it could happen. And the severity, you can have a fire that will kill the trees but not burning the soil, leaving a lot of tree alive. Or you have a fire that will kill all the trees and will burn a lot of the organic matter. So it creates a large amount of variability, which we call the natural range of variability. And what we don't want in our management is to be outside. We could be at the extreme, having a non-native species on very short rotation with site preparation, so high severity, short rotation, etc. So we would be out. But what we want is maybe to be in the natural range of variability, but maybe not cover these big 5,000 square kilometer fire, but try to keep some kind of variability, but not all the variability. So it's the same figure, but looking in time, in managed forests. In unmanaged forests, there's a lot of variability, temporal variability. Sometimes you have big fires, so the forest has to recuperate from the fire. And managed forests in general, we reduce the variability through time. So again, if we could find a way to decrease this difference, that would be the best solution. So let's look at some of the main aspect or the main issue where we have difference between the way the nature is disturbing the landscape compared to forest management. And as a comparison, I just show you the management, which is more easy to explain than the natural disturbance, because of course it's more simple. In most of the boreal forests in Quebec and Ontario, what is done is a CPRS or CLAG, which is a cut with protecting the regeneration and the soil. So I would say that 90% of the boreal forest is cut that way. So it's clear cutting with protecting the regeneration with where the machine are going only in skid track. I guess you and forestry, I don't have to explain that to you. You probably know better than me. But that's what it looks in a cutover, in a large cutover. You see these in the black spruce. I think in Quebec it could be 250 hectare a cut, and then you have a band and another 250 hectare cut. So if you look at the landscape on the long run, and you have the cut after the cut, you have this landscape. And if you look from a different perspective, you have these way of rolling the forest from south to north, with the natural forest close to the commercial forest limit and the forests that were cut. Here the purple color is big fire. So the green is recent cut, and the purple is recent fire, and the dark green is the pristine forest north of the, very close to what we have as a northern limit of for commercial forestry in Quebec. So there's a kind of a modern myth. It's interesting because I'm giving talk after talk, and it seems that everybody is convinced, but it takes time to change this idea. But it's still, if you go in a textbook on boreal forests, it will be written that the boreal forest is controlled by fire, large scale, so clear cutting with short rotation adequately emulate natural forest mosaic. Okay, that's true for part, but not for all. So that's the main problem. So if we look at the main difference that we can see between fire regime and current forest management, I will insist on the main or the most important issue is the decrease of old growth forests. If you have I'll go through the slide, but simple. It's that if you have a cutting rotation of say 100 year, you have at the end when you have cut all the area, a forest that is 50 year old on average. Okay, but if you look in the landscape, the natural forests are older than that. The average age in the landscape is much older, and probably very old in the eastern part of Canada, and a little bit less when we move in the western part. But if I have time, I'll talk about other issues, which are the spatial pattern at the stand and at the landscape scale. The disturbance severity on soils, something that is very important in the area I'm working the most, which is the clay belt, where you have a lot of organic matter accumulation. And as I'll go towards during the talk, I'll talk about the possible solution that we can have. So most of the work we've done were in this transect in between Quebec and Ontario, a large transect of 15,000 square kilometers, where we reconstruct the it's a time since fire map. We reconstruct the time where the stand were initiated by fire. So it gives you an idea of how well are distributed the stand age over all the landscape due to natural disturbance. So the color represents the last fire. When it's red, it's recent fire, so it's really the imprint of the fire, of the last fire. But as you move in time, it is most what has been left from the successive fire. So it's not exactly where the fire burned, it's what was not affected by fire since that period. So you can see that we can go up to 1700 and older, up to the present. And that it's a mosaic where you have patches all over the landscape. The 49 is the latitude is the limit between the black spruce, pure conifer forest, and south of the 49 we are in the boreal mixedwood, where you have a lot of aspen and birch mixed with the conifer. So I will use mainly that as an example. How we reconstruct that, but we had the old aerial photograph that were taken just after the First World War in 1920. We had archive of fire that are quite good from 1940. And before that, we just went in the landscape, we core the trees. Mainly we select jack pine or trees that mainly came after fire. And often we use the snag. It's very interesting. Jack pine can die and stay as snag for 100 years. So if you cut the snag and you cross date with living trees, you can go back in time and have a long fire history. Another way to look at the map is just to look at the proportion of this map in regards of the time since fire. So it's just an histogram based on the proportion of the stand initiation map. And clearly what we can see is that 57% of the stand are older than 100 years, and 23% of the stand are over 200 years since fire. And the mean age over the landscape is about 140 years. Okay, and you see that normally we should have a huge peak of fire in the recent. It should follow a negative exponential distribution, because the fire tend to produce young stand, and those young stand have less and less chance to be in the landscape because of the burning frequency. But clearly what we have here is that during the 28th century there were a big decrease in fire frequency, which is I'll come back on that, which is a good news, because we have less fire today than we had in the past. It's not part of my talk, but it's not linked strictly to fire suppression. It's mainly climatically driven. The 28th century climate was more wet during summertime than it was during what we call the Little Ice Age in the 19 and the 1800s. So here it's the difference. You forester, you will understand these distribution. That's the distribution that generally we want in forestry when we want to regulate the forest. If the forest rotation is say 100 years, to make things simple, we would have a distribution like that. But if you have a fire cycle of 100 years, because fire cannot know the age of the stand, so it's a random process. So it doesn't follow this rectangular distribution. It follows a negative exponential distribution, where we have about 37% of the stand that are over the cycle. So a 100-year forest rotation, managed forest, and a 100-year fire cycle are completely different. And if you look at the abundance of old-growth forest, in one side you can have a lot, in the other side you don't have any. So that's one of the big difference. So the reason is that because the fire is a random process, and a part of the landscape can burn twice during the time another part of the landscape get older. But you have, again, 1% of the land base that is burned every year. So it made this is the difference in the distribution of an early cereal stage to old growth. If you compare a 140-year fire cycle, what we observe with the mean age of the forest in western Quebec, and the forest rotation, so you see that we lose the over-mature and old-growth forest in the landscape. So we did that in many parts of Quebec, Ontario, and I look also, I'll show you later the study that were done elsewhere in Canada. And what we found, it's about the same everywhere, with a small difference if we go from western Quebec, where it is drier, to eastern part of Quebec, where we're closer to the Atlantic Ocean, where it's moister. But we always have a significant proportion of the forests that are naturally over 100 years. So over the forest rotation. If we look in Canada, there's many studies that were done by different researchers in Canada. I just picked some of the study, and we have the same thing. But of course, if you are in Alberta, there is less old-growth forest because the fire cycle is shorter than if you are in Labrador, where you have a very long fire cycle, say 500 year compares to 75 or a year in Alberta. But there's a significant abundance of old-growth forest. And if you look to this map, it's interesting. I don't remember the reference, but it's just based on the inventory in Canada and the US. They look at the age of the forest in the inventory. And you can see here the abundance of blue which correspond to forests that are over 100 years. And you can see all the fire in the center of the country where it's younger, and of course the Rockies where it's quite old, and of course in this part of the landscape it's mainly related to the harvesting that occur. But in the area that is still under natural process, we can see that we are the owner of a lot of old growth forests still present in the, I think it's 2004. So maybe there's some that there are less today than on that. And the forest can be very old. Here we look at the forest, we cannot age with the tree. And so we went and we look at the charcoal and do C14 analysis. And some of the forest can be thousands of years old without fire. So it's interesting to look, and it followed the negative exponential distribution. It's just by chance there's part of the land base that doesn't burn for a long period of time. So then we look at through the Holocene, what was the variability of the fire frequency through the Holocene. So to do that, we look at with the group of French researchers that were specialists in reconstructing fire history with charcoal layer in the cores of lake. So we core many lake in both in the south in the boreal mixed wood and in the north. And now I think they've cored in Quebec more than 30 lakes, so they have a very good idea. So we can look at the fire return interval, looking at the different layer of charcoal that are deposited in the core. So we just plot those interval between two successive fire in the core for a different lake, and we look at putting all the data together to have an idea of what was the distribution of fire interval through the Holocene. And we were able to look at the fire-free interval that was, say, between 300 years during most of the Holocene to a period that goes to 100 years. So it goes from 100 to 300 on average. So if we look at these mean fire-free interval with 100 and say a little bit more than 300, it gives you an idea of how much of the old growth forest we had in the past during all the Holocene. Okay, we can just look at the amount of forests that are more than 100 years old, considering this interval or this variability of the fire interval through the Holocene. And here we have the value that are reported. And what we can see that is interesting is that never we had less than 30%. If you want really a floor that we should not go below, it's 30%. During all the Holocene, there were always in the landscape 30% of forests that were older than 100 years. And the X here represent what we have in 2010, okay, in the land base. So we see that we are out of the natural range of variability for this amount of old growth forest that is half of what was the minimum in the Holocene. And this is not surprising, because if we look at the area and we look at the fire in red and the cutover in yellow, we can see that there is far more yellow than red. So we have we cut at a rate that is higher than the natural fire frequency. So there's a good news. In fact, it's the good news is that the historical rate of disturbance, which I put here, and in parentheses, this is the fire cycle. If we look at the last 300 years, for instance, what was the historical rate of disturbance by fire, and then we compare to what we have in the archives since 1940. And when we see it's a huge decrease. So there's a lot of room to replace fire by logging. So that's the good news. I mean, without the logging, and if we keep fire suppression, we will have a problem of young forest in the landscape. We will lose these young forests in the landscape because in the past they were more produced by fire than today. And you see that it's a huge decrease all over the study we've done in Quebec. The problem is that the cut rotation in the east, at least, it's well over the natural fire frequency. I mean, there's room to replace fire by logging, but we use more than the room we have. We cut more than what historically the fire was doing in the landscape. So here I have the real data from Western Quebec, and it shows what was the abundance in 2010 without the logging of forests over 100 years. It was 50% in the land base. If we add the logging, then it decreased to 24%. This amount here, 56%, is an amount that was produced by modeling just using the negative exponential distribution and say according to an average age of 140 years over the landscape, we should have 56. So without the logging, we were not too far from what is modeled. So it was, but we go to 24%. And then we have this new Forest Act where we're supposed to go to ecosystem management. And if we don't log and we let the forest age, we will increase a huge amount of forest that are old growth. The reason for that is that because most of the fire during the 28th century occur in 1910 and 1920. So those forests are ready to be cut. So if we don't cut them, they will pass the 100-year threshold. So without the logging, there would be a lot of forest. But with the logging and the current fire frequency, we go from 24% to 19% in 2030, according to the timber supply that is used in Quebec right now. And if we go in 2050, then we are at 15%. So we are decreasing, in fact, the old growth forest. Right now, if we do the forestry the way we plan to do it for the future. And then what about the future fire activity? Because this is based on the current fire activity, but there's climate change. And we know that with climate change, that might change. And here we did a study where we use, I don't remember, I think it's 17 different scenarios, because you have different GCM model and you have different scenario of how the way we could cope with decreasing or increasing the carbon dioxide production. So we just simulate what would be the climate in the future. And of course, the climate in the future would be higher temperature and higher precipitation. But what matter for the fire, it's more the drought. And the temperature is increasing far much compared to the precipitation. So we are going towards something that will be drier. And here it's shown by the monthly drought code, which is correlated with the area burn. It's the best correlation we can find with the area burn. And we have for the month where the fire season, you have an idea depending on the model, what is the variability, but all the models show an increase for the mid 21st century and a higher increase again for the end of the century. So clearly here you have the increase. We are in a very relatively low fire cycle between 400 and 500 year fire cycle, and we move toward the close to the 1 person per year in one of the model, which would be a 100-year fire cycle. So there's clearly, with the modeling, an increase. So here it's the variability during the Holocene, where we are, and where we are going depending on the scenario. So we are going back, in fact, to something where we that naturally the forest has that naturally happened in the forest during the Holocene. But the problem is more a problem of economy. If the fire is burning all the wood you want to log, then you're in problem. But ecologically, the forest would be resilient because they have there were periods where this 100-year fire cycle occurred during the Holocene. Okay, those and all we can show that with pollen analysis that all the species were there, not in the same proportion, but they were all there. So it means that the fire cycle was not that short that balsam fir and white cedar were gone, or that long that the jack pine was gone. So it means that during the Holocene there were enough of variability that all the species were there. But clearly there's a potential economic problem, and it's just what I show here. If we apply rather than applying the current fire cycle, we apply the future fire cycle, then we have a decrease that is more important in the abundance of old growth forest. So why caring about these old growth forests? I think I don't think I have to convince you that they are important habitat, and the way we want to preserve biodiversity, the main way is to go towards a coarse filter, where if we keep the habitat, we will keep the species. Of course, there's we call it the coarse filter, but we also need some fine filter for some species. And in Quebec, in the boreal in Quebec, it's mainly the caribou that is the focal species, which is really important because it needs old growth forest. And spatial attribute, not too much road, because if there's road, there's predator that are coming in the caribou herd. So how different are the habitat in regards of time since fire? I just wanted to illustrate here the boreal mixedwood, where we have fire and different date, and you can see that we start with hardwood forests that could be an aspen or birch, and we go to mixedwood forest, and then the old growth where we have white cedar and balsam fir with spruce, white spruce that are mixed. So there's very different habitat that are represented here with this figure, where you have this transition toward from a hardwood forest to or broadleaf forest to conifer forest. It takes about 200 years between 200 to 300 years to go from the pure aspen or birch stand to the pure conifer stand. If we go in the conifer forest in the north, it's more a change in structure. You can have these jack pine or black spruce that come immediately after fire, but if you go in very old growth forests, you have a change in structure where you go to irregular stand to uneven age stand. So different structure, but the same species. So we call it first and second and third cohort in regards of time since fire. So here it's the same graph showing that you can go from, say, from jack pine to black spruce, but then the black spruce could come immediately after fire, but change in the structure from irregular to uneven age. And again, it takes 200 to 300 years to go from one stage to the other. Here it's just to show that if you have only the first 100 year, you cannot keep all the species, so that you have a cumulative species curve that show for different species. If you go with lichen, there's not much problem. It's terrestrial lichen because you have terrestrial lichen right away after the disturbance. The vascular, you have to wait. You have 100% of the species, say 150 year. The mosses, it's a little bit longer and it's continued to increase. The liverwort, then it takes a long time before you have the 100%. So if we stop here, there's still some of the accumulation of species that we have in the old growth forest. And there is a lot of animal, and I'm not a specialist in animal, but Pierre Drapeau, who is working at UQAM, has made many studies showing that a lot of woodpecker are associated with old growth forest because they are looking for snag that are present in old growth forest, and there's many species that are more abundant in old growth forest. There's the marten, that is a case also of a species that is more abundant in the old growth forest. And of course the woodland caribou, that is the main issue right now in Quebec because it's an endangered species. So there's a lot of concern about the abundance of the woodland caribou. So the question is what we want to do. What could we do? Of course, there are species that like young forests. There are species like the moose or the hare that are more abundant if you have a hardwood forest, young forest. But there's all these species that maybe are more cryptic, the mosses and some epiphytic lichens and insect that we can see in the old growth forest. So we have to find a way to keep them in the system. So then I go to solution. In fact, there's 3 types of solution, and probably the solution is a mixture of the three alternative. One is the triad approach. You are probably in one of the province where it's the case. It's to go to intensive forest management and part of the land base. And because you are producing a lot of wood, because you have plantation, etc., you can spare more of the forest than normally you would spare with just conservation. So rather than having 12% conservation, you can have 25% conservation or 30% for the same amount of wood that go to mill because you increase the productivity per hectare. So that's the triad approach where you have intensive forest management, extensive forest management, and conservation, and you vary the proportion. Of course, the other way, it's you can wait longer. Why logging at 100 years? Okay, there are some forests that when you pass the 100-year stage, the biomass stay the same. Okay, it's not true that it's decreasing. Of course, there's a decrease if it's not logged at a certain point, but it can go 100 year, 200 year, 300 year, and it will keep the same amount of wood, and because it's renewed. So we could extend the rotation. That would be a way that to do it, maybe to rather than log at 70 year, wait to 100 or wait to 10 year later. Just change 10 year, change all the age structure. Or what cost, and it doesn't cost timber supply, it's to change the cutting practices and to do partial cutting and try to emulate or to recreate the old growth forest, because you don't do just clear cutting. But then, is it something that will preserve all biodiversity? Maybe not, but most of the studies show that if you do partial cutting, it's better than clear cutting. It's in a kind of a intermediate. So the triad, Here it's an example, and it's just the problem with the triad is that we have to be prudent, because there's people that have tried that. If you think of Finland and Sweden, they have for a long term go to very, very intensive forest management. And if you look at the threatened species, the red list species in Finland, there's 1,500 threatened species, mainly because of lack of deadwood and old-growth forest. Of course, they know the species better than we do, so they can put more lichens and mosses on the red list. But I guess there's one of the aspects we have to be aware that with intensive management, we can lose some of the species. That's really not the case right now in Canada, at least in the boreal, because we are in general to the first cut. So there's a lot of forest that was left behind, so there's many places for these more rare species. But we have to be prudent. You see here, it's from Finland. In 1921, they had 79% of the stand that were irregular. Now they have 44%, especially in the north. And they had these two-story stand, Scotch pine stand, where you have these surface fire that keep the big trees, and you have regeneration under the big trees. But it has increased a lot. So they have replaced in some way these old-growth forests with Scotch pine plantation. Okay, emulating fire cycle would imply the increasing forest rotation, or to designing silvicultural treatment that emulate the composition. So either we increase the rotation, or we vary the silvicultural treatment. Here we have what would be a distribution of the stand age in regards of a time since last clear cut. If we vary rotation, so we can say we cut 63% of the land base at 100 year, 23% at 200, and 14% at 300 year. And or we vary the silvicultural treatment. We clear cut 63%, we partially cut 23%, and we selectively cut 14% in order to keep old growth that were a gap. That had gap dynamics with selection cutting, succession from the first chord to the second chord by partial cutting, and clear cutting to mimic or to emulate fire. So the advantage of that is that it costs more to do partial cutting or selection cutting, but there is no effect on the timber supply. Okay, because you cut the same amount of wood, it's just that you cut it a different way. But in terms of the abundance of the amount of wood that is cut, it could be the same. If you extend the rotation, then you could have a loss because of the mortality in the stand. So it costs less because you still, in money, you still have clear cutting as the main way of cutting the forest, but you lose some of the timber supply because some of the tree will naturally die. We have experience, Laval University have experience on the Quebec North Shore. There's many places where there's a partial cutting experiment in the boreal. The government is planning some. I think in the Quebec North Shore they have these partial cutting in close to 15% of the stand. In Western Quebec it's probably less than 2% of the stand. So we're far away from the amount that would be needed to keep the old growth. But there is experiment. We've done experiment. The idea it's to go from an old growth forest. Part could be clear cut, part could be partially cut, and part could be selection cut in order to recreate the natural dynamics, but rather than fire, then it's clear cut that is that replace fire, and it's partial cutting that replace succession, and selection cutting that replace gap dynamics in EVNH. I don't know the time. 5 minutes? Okay, so I'll just skip the spatial pattern and the stand landscape, I'm sure, and I'll just go to the severity on soil, because this you're very used to that. I'll go fast, and you see it's large part in large spatial pattern that that we have here on your left. You have what happened between 1973 and 1997 as a fire, and you can see that the patch of fire are all distributed all over the area. But if you look at the logging, you see that the logging are concentrate in the southern part of the land base. So it's a very different pattern. So now they use compartment to force the forestry to go all over the land base and not to roll the carpet like it was in the past. So we want to stop that and try to keep a good distribution of a uncut forest in the land base. Okay, so I'll just go fast. That was the idea of using the clear cut, partial cut, and selection cut in large compartment in such way that you can partially cut some place and clear cut other place, but you have to distribute that in the land base in some way, in the same way than the fire was doing it in regards of the age. Okay, there's also the green tree retention inside a fire. It's untrue that when you have a fire, everything burns. Here you have the area in yellow are partially burned, and the area in green are unburned. So you have a variability of intensity or the mortality of the tree on the land base. And here it's for different fire and different year, the amount of partially burned and unburned part of the so a big clear cut without leaving tree is not like a fire. I don't have to. So we tend to move from what we had in the past, which was to leave band around lake and river and band between clear cut, to all kind of tree retention into the clear cut, single tree retention or patch retention in such a way that it emulate better the fire. Well, disturbance severity on soil, I'll make my argument quick. The main difference is that if you have a fire, it will leave part without organic matter and part with a lot of organic matter. But when we clear cut, especially when we clear cut in winter with CPRS, we generally leave the organic matter everywhere. So we don't produce this recycling of the organic matter. So there is no effect, physical effect, and there's no chemical effect because it doesn't burn. So there's a problem of replacing a process where you burn the organic matter to a process where you don't burn the organic matter. And I guess in several cases we will be in problem with productivity because of this lack of emulating the process. And in the part of the world I work with, there's this paludification process, which is clear, which shows that with time you have a change in the succession of the mosses. You go from good mosses that are the feather moss to good sphanium to very bad sphanium. And as you have the increase in organic matter, you have these water that the water table that move outside, inside the mineral soil. So the new cohort of trees are no longer have access to the mineral soil. They have to grow in the organic matter. And organic matter that is produced by sphanium is very fibric with very few nutrients. So just to make a story short, we look at some of the stand, very old stand, and we look at the first cohort of tree, second cohort, and the third cohort. The first cohort was growing on the mineral soil. The second was growing on the deep organic soil, and the third cohort was really growing in the fibric layer. And when you look at the site index of those trees, you go from 12 meter at 50 year, which is a tropical forest for black spruce in the northern part of Quebec, to something that is 2 meter at, so it's huge decrease in productivity in tree cohort of trees. Okay, I'm not saying that it's like that everywhere in the boreal, but this is an extreme of the situation. And when you have a low severity fire, it's what happened, because when you have a low severity fire, the next cohort that come after the fire, they have to grow in the organic matter. So the low severity fire, we were able to see right away that the productivity was lower. You don't have to wait 3 cohorts. It occurred immediately after the fire. So it's something that the Finn have observed. You know, the Finn they were partially cut the forest before 1960, I think. And then there was a guy who was Siren who did a PhD and showed that if they were continuing to do that, there will be a decrease in productivity. So they switched to clear cut because of that. It's interesting to show that we tend in forestry to apply only one recipe and not to mix recipe because they move from so 2 different pathways depending on the high severity or low severity. And what we are producing, it's low severity fire because we log during winter, and we emulate the low severity fire, the one that produce not very productive stand. So there would be solution, site preparation, prescribed burning that should be done. And here, just result of the growth of black spruce in summer clear cut, prescribed burning, winter clear cut, and clag, which is CPRS, but in Ontario. And you can see that there's a big difference in the height of the black spruce. So it means that it matters. And if we want to keep the productivity, we have to keep the process. So here it's a complex graph showing that if you have problem, if you go in a stand and you can see that it will palidify, then you should clear cut, site prepare, burn, and go back. But if it's pleurodrome, then you know that you're good for another rotation. So then you can partially cut because you will keep some productivity. So the message in that is that you have to know your sphanium, your good, your bad sphanium, your mosses, and then you will take the best decision. But it's not always clear cut and it's not always partial cut. It's a mixture of the two. And you have to keep the same basin of the first cohort, second cohort, and third cohort in regards of the partially cut, selection cut, and clear cut. So conclusion, current forest management is driving eastern boreal forest outside its natural range of variability. Important diversification of silvicultural treatment is needed to meet sustainable forest management objective. Selection of silvicultural options should integrate both stand structure and potential productivity. It's not just a question of keeping the structure, but also to think of the process. I think we haven't, in ecosystem management, we have insisted too much only on green tree retention and structure, and not enough, I think, on the process. So thank you.
We do have some time for some questions.
I was just wondering, so if you start doing more partial cutting, as you suggested, would you need like a more intense road system? And have they looked at how that would affect the woodland caribou?
Yeah, I think it's a good point. It's more partial cutting. It means that you need more road. The problem in Quebec, I think the only solution left in Quebec is to plant the road, to use the road only once, and to plant it. Because the main problem with the woodland caribou, it's not the logging itself, it's the road. They don't move around the road. And if you have many roads because you have mining, you have road because you have electricity transport, and then you have road because you log, then they start having a big problem. So I think one solution would be to just deactivate completely the road when the logging is done. And the partial cutting, it's not like in the hardwood forest that you go back every 25 years. I guess you take, the idea with the partial cutting is that if you take, say, 40% of the volume, it means that your stand that was 100 years old is now 60 years old. So you will go back in 40 years. So, but I agree that it's one of the problems. The road, the cost, because it costs more. But on the other hand, it produces larger wood, so with more value. And if you do partial cutting, it means that you will agglomerate the clear cut, because if you want to emulate fire, you can make large area in clear cut, and then a compartment where you do partial cutting, so you can save money because you agglomerate the clear cut. And of course, you will keep your certification. So I guess there's a lot of things that could be positive, but there's also other problems.
Sounds like a good master's project.
Staying within the range of natural variability is one thing, and I'm wondering if you see that as any different than ensuring that you pass through the range of natural variability. Do you see what I mean? I could reside at the bottom of that range, or the top of that range, or the middle of that range, but is that the same as actually having a system move throughout the range and benefit from whatever results from being at extremes, moving to, from minimums to maximums, and moving to that whole?
Yeah, that I think that the question there is no reason to have sustainable yield. There is no ecological reason for sustainable yield. It's an economic reason. It's because you want the mill running, you want the job running. But we could say we stop logging because the price of wood is not good for 20 years, and then cut in 1 year the 20-year accumulation of wood supply. There's no ecological reason to not do that. So if I understand your question, is that having always the same amount, doing always the same thing it's the rational is more economic. It's not ecologic. So I wouldn't be against not logging for a couple of years because the price is not good.
I guess it depends on the size of the footprint that you're making that decision. You could have a very variable harvest going on this part of the landscape, offset by something that's out of synchronization over there, and end up with an even production overall, but very different continuity within the two areas or the three areas.
Yeah, there's a question. In Quebec, we tend to apply this approach to the forest unit, which are close to, in the boreal, to 5,000 square kilometers. So 5,000 square kilometers, the average age of the forest overall, the landscape, is relatively stable. So if you have something that is relatively regular, you wouldn't be too far from the nature. If I move to northern Alberta, where you can have huge fire, then the forest unit would have to be very large to keep this kind of average. So that we're in some way lucky that we have these forest units that in some way represent something that is relatively not really at equilibrium, but relatively stable without a big variance.
One of the things that you said earlier on about the distribution of plants and animals throughout the Holocene during different climatic cycles was that they're basically all still there throughout the land base, just in different quantities. Given the fact that the climate is warming and we're expecting to see some of those species distributions change, does that change how your indicators are going to work for good and bad sites? Or?
Yeah, that's a big issue, this question of climate change. I guess the ecosystem management in Quebec is challenging now by that, because the argument is that why trying to emulate something that no longer exists or will no longer exist? So I guess the only thing we can do is probably to work on trajectory and say the best example is probably south of the area that probably look more with the Acadian forest, where you have a mixture of conifer and hardwood, real hardwood. And you can clearly see that the real hardwood are taking advantage on the conifer. So it's easy to just say, I will increase the amount of hardwood. I will favor place where I can increase the amount. I know that the company will not like that. But on private land, it's okay. It's a triad. So it's okay to keep the conifer. But I mean on crown land, you can say, I will push more on the trajectory that it's normally going, and try to not force keeping the conifer. So I think that's the only solution that I can see. It's try to adapt our target in regards of what the climate change is bringing in the landscape. Because for black spruce, if you go in 2100, black spruce is gone in the boreal, according to model. But it will be there, still there at many places. There's still a black spruce around Montreal, but it's in wetland. So it's the mesic site where we should maybe start to favor white spruce rather than black spruce, because we know that in mesic and dry site, black spruce will not be in the comfort zone. So that's the way we should go. But it's a big challenge, I agree.
Any advice on applying the natural disturbance concept to the Acadian forest? You don't have the natural template like you have in Alberta and northern Quebec to see what fire or other disturbance do. But we do have budworm events. So any thoughts on that concept applied, let's say, to budworm?
Yeah, budworm, the way we apply budworm in the boreal mixedwood, it's clear that some of the partial cut and selection cut is to emulate the budworm, because of we have a lot of stands that were mixedwood that now are dominated by broadleaf. So the idea of keeping those stands as mixedwood, or to move a stand from conifer to mixedwood because we partially log the conifer. So that's the way to integrate the budworm as a component of the dynamics. So it's not only in our case fire oriented. The budworm, I think it's a big problem, because it's more difficult to. Fire is easy. You take the negative exponential and you find the abundance of a stand that should be at the budworm. It's something that occurs in old growth forests, and it's an event that affects a huge area. So it's very difficult to find a way, an easy way to emulate this kind of I think it's possible to emulate, no problem. You can do partial cutting, you can do selection cutting that emulate. It's to reproduce that in a forest unit as a proportion that is a problem, because it's something that occurs as a single event and affect all the forests in the same time. Fire is a random process, so it's more easy. So you have to ask Dan Nisha to come and ask the same question, and I'm sure he will give you a better answer than me.
Well, last year actually I have a visit in most of Sonoma River. Danisha showed us the bogworm damage there, and it told me the biggest problem there is they don't have enough road to do the silage logging. But I just want to ask, because we don't see lots of insecticide spray in Quebec and all, and is that related with the ecosystem management idea?
No, I think we spray with BT, but not with chemical product. That, I think, is the difference between New Brunswick and Quebec. Did you still use no? Okay, it's for the vegetation that in Quebec we don't use so I think, but you know, they spray to be able to keep the forest alive enough that they could salvage, but they know that it's not in spraying that they will stop the budworm outbreak. So it's more a question. So I guess if they don't spray everywhere, it's a question of knowing that they won't be able to salvage. And right now in the Quebec North Shore, it's so big that there's no way that they could save the forest, especially that commercially there's a very few companies that make profit with the forest, considering the productivity of the forest. So I guess there will be a lot of mortality, and many of the stand won't be salvaged.
The negative exponential, the mathematical negative exponential assumes equal area burned each year. So that's not what happens in reality. So does using that actually result in distorting your estimate of the range of variability?
Not really, because most of the empirical distribution follow the negative exponential. Okay.
In general, but specifically they don't. But you have much higher than much lower.
But you know that the idea is that when you manage, you have to manage with. It's very difficult to manage with a stochastic function. So the negative exponential is better than the regular distribution. So I guess it's a choice of going towards this type of distribution. There's a more fancy distribution, such as the Weibull distribution, but we were unable to show clear effect of age on the chance of burning. Most of the stand, as soon as you have a conifer in the forest, even the plantation, they burn as often that old growth forest. So I think it's really a pragmatic choice more than but if we wanted to clearly emulate the real nature, we would have probably to come back to your question, to have something that is more stochastic and that produce the logging in such a way that some year it goes at that abundance and another year at the other abundance. But I don't think that I would convince forester to go in that direction. I think it's already to manage with the exponential negative is a big change.
Okay, well, on behalf of the faculty, I'd like to thank you very much for your presentation today. There are other treats and so on, so I encourage everyone to have some. And again, thank you very much for your presentation.
Thanks.